Hello and welcome back to differential equations. After these 40-minute technical difficulties, we are finally on track, starting chapter 5, talking about the first order systems and applications. So as you have systems of equations where you might have multiple variables x, y, z, and so on, following having 2, 3, or 4 equations. You can have the same thing with differential equations where you have multiple unknown functions. These differential equations could be coupled or uncoupled, which means if they're coupled, that means that they share variables. If they're uncoupled, they don't. So we'll see some of that stuff down the line. I would like to first define how this looks like. So definition, we are going to take a look at f of t, x, y, x prime, y prime equal to 0. And then second equation, g of t, x, y, x prime, y prime for the second one. And the solution is a pair. Solution is a pair x of t, y of t. So you will have, for each variable, you will have one of the functions. I mean, for each function x or y, you will have a function as the answer. So you can be provided with initial conditions as well. That also goes into the mix. And I want to take a look at some of these equations. Since I know how much you love circuits, we're going to start there. So in this case, you're going to have 2 loops, right? 3 branches, 2 loops. And if you have that, you can write 2 loop equations. So let's draw a circuit. We have the inductor connected to the capacitor, which is connected to a resistor, R, 25 ohms, capacitor, 0.008 farads, inductor, 2 henries, with another resistor, which is 50 ohms, and all of that goes into a source which is 100 volts. I put this side 100 volts. We are going to put 2 loops, current loop I1, loop I2, and the current I, right? Now, in the introductory section, we are only interested in how to set these systems up, not how to solve them. So we're only setting up the problem now, and solving these systems is the next section, which we should have enough time to do today. So we start writing the loops. So the first loop, we have 4 inductors. Inductors. What happened?
Your DC and DC inductors and capacitors.
Yeah. So it's AC. Because you don't really get to write the differential equations for DC. Only for AC. Direct currents don't. Yeah.
Yeah. It acts as a short circuit for
Yes.
capacitor and
Inductor. Yeah. Well, capacitor is just the open switch in that case.
capacitor is small.
Who said I have no faith in you? All right. So what do I have? 2 di1 over dt. That's the voltage drop on the inductor. Plus 50. We have both of these currents. So I1 goes down, I2 goes up. So I1 minus I2 equals 100. So voltage drop over inductor and the resistor equals the input voltage. What happened?
Machine.
All right. Now the other side. So we have 1 over C, which is 1 over 0.08, right, times Q2 plus 25I2 plus 50, and now should be I2 minus I1 because they're again opposite. And that all equals to 0. There is no source on this one. Okay, so 0.08, 1 divided 125. Q2, Q is the derivative, right, of Q2. Yeah. All right, so, but Q2, wait, Q2 is on this side. Yep. So I2, okay, so that's di2 dt. I2, so plus 75 I2 minus 50 equals to 0. This is equation 1, this is equation 2. Okay, now let's clean them up. The top equation can be divided by 2. So I have di1 over dt plus 25I1 minus 25I2 equals to 50. And the second equation is divisible by 25. So that would be 5 di2 dt plus 3I2 minus 2I1, I should have swapped them, equals 0. There they are. So you are seeing over here, you are seeing the system of equations. You have the derivatives and the functions. You are clearly looking for functions I1 and I2. Now we'll learn how to solve this in the next section. This is just a setup, so we are using the loops to write these two equations. You have two unknowns, right? I1 and I2. So you can figure out what those are. Solve in next section. That's what we have. So solution, solving this will be next section. Moving to the next example, because we want to know what happens once you come up with these equations. What happens if you have one crazy equation and you want to break it into a system to solve it? So here is an idea. Third derivative of x plus 3x double derivative plus 2x prime minus 5x equals to sine 2t. Now we should be able to solve this by factoring, right? You correct characteristic equation for the third, so you will have r cubed plus 3r squared plus 2r minus 5 equal to 0 to do the homogeneous case and go on. And hopefully you can factor it and you know, finish off the problem. But there is a really cool thing that you can do. You can write all of the derivatives in terms of new variables, functions, right? New functions, and then create systems of equation. So you can define x1 to be x, and x2 to be x prime, and x3 to be, sorry, x2, yeah, to be, yeah, x prime, and x3 to be x double prime. So you define new functions. And now if you observe, x2 was x prime, which means that that is x1 prime. And x3 was x double prime, which means that's x1 double prime. And hold on. Yeah, which is x1, so x2, okay, so that's x1 double prime. X1 double prime is equal to, if you look here, right, x1 double prime, that's equal to x2 prime. So meditate on this line for a second to see where that is till I check with you on.
Could I borrow an extra mark? Extra mark? Yeah. Or two if we yeah. I have
2.
Yes.
You. So one more time. New function x1 that I'm using, like, you know, substitution u equals x plus 3, right? That's it, all right? U equals x plus 3. So the new variable, new function, I can use u, v, and w. Or I can use x1, x2, x3. It doesn't matter, right? If it's going to make you happier, I'll use u, v, w. So x1 is x, x2 is x prime, and x3 is x double prime. Now, x2 is x prime, but x prime is x, if you differentiate, right, is x1 prime. Because you want all of your functions to be in terms of x1, x2, x3, and so on. So you have x to replace with x1. Now you have x prime to replace with x1 prime. You need this as well. So x3. x3 is defined to be x double prime. But x double prime, if you differentiate this guy, double prime, x double prime will be x2 prime. So x2 prime. And now, let me circle all of the equations that you are actually going to use. You are going to use this equation here, and that x3 is equal to x2 prime, this equation here, and you are left with one more. You have to have that x cubed. because you have 1, 2, 3, 4 different things. So far you have 3 equations. The last equation is third derivative there, written in terms of the other functions. So, actually wait, we don't need it, right? x1 prime, I have x1 prime, x2 prime, and then x3 prime, which would be the double derivative. Okay, so x3 prime is x double prime 2. I think that's it. So what are the equations? We start with x1 prime. Don't need this one. x1 prime is equal to x2. And then we have x2 prime is equal to x3. And we need x3 prime. Now x3 prime something is off over here. I didn't put the prime there. X3 prime. So that's done. That's done. X2. X double prime. So that. So solve this one now, because that's x3 prime. Okay. So x3 prime is this one, which you solve the entire equation. What do I have? If I move everything to the other side. So 5x goes to the other side, negative 2x prime, all of these. Okay. So x1 is equal to x. So first of all, sine 2t stays. This term goes to the other side as positive 5. Instead of x, I'm putting x1. Now the other term, which is 2, goes as minus 2. X prime is x1 prime, which is equal to x2. Good. And finally, minus 3 goes on the other side. So minus 3, x double prime is x3, so just x3 over here. Damn, there we go. Whew. And here's the system. This is just a setup. We're not solving it yet. All right, so this been a little bit rough, so let me explain it one more time from scratch, so that half of you are on the same page. No, I'm serious. Like he's out and the other one's out, so half of you are on the same page. It's okay. You have a streak, so you can equally not understand that. I'm on the roll today. I'm really happy. I had only 3 hours to sleep last night, so I read how to do these tutorials. It's awesome, and I also had to play something. Yeah, it's never easy, man. Life is challenging. Okay, so we can see the problem, and we can see what we have is the third order differential equation with constant coefficient. It's non-homogeneous, right? Because it has sine 2t on the right hand side, and we want to solve this by using the system. Now, system will involve coming up with new variables. So we start with x1 equals to x, and then x2 equals the prime, and x3 equals the double prime. So 1, 2, and 3, those are the ones. And now when you differentiate, you see that you get, when you differentiate this one, you get, since this is equal to, since x is equal to x1, you differentiate both, you get that x2 is x1 prime. Same trick here. You start with x cubed equals to x third 3 is equal to second derivative of x, and then you realize that this and this is the same, because if you were to take two derivatives here, two derivatives there, so that replaces it. But that in terms is equal to x2 from this one if you differentiate this. So that's another substitution, leading us that x3 is x2 prime. Now you get to differentiate one more time for the third derivative here, but we don't have to because we already have enough for the solution. So here's the first one. You look for those equations that have a prime in it. So x1 prime, x2 prime, and x3 prime. We don't have x3 prime yet. We'll deal with that. So x1 prime is equal to x2, and this equation x2 prime is equal to x3. Those are the two equations that we take. Now we move to the next one because I need that third derivative. The third derivative will come from differentiating x for the third time. So that's going to be, if you look over here, that's already x double prime. You differentiate both sides, right? If you differentiate both sides, you get that x triple prime is equal to x3 prime. So now you have that one that is, and then that is equal to x2, if you are to differentiate another blue equation. So it's a little bit chasing around, but we got it. So now we know that the triple derivative on x is equal to the x3 prime, and then you just move everything else to the right using the substitution that you have along the way. For x you have x1, for x prime you have x2, and for x double prime you have x3. You plug them all in and you have the system. You have three equations, three unknown functions, and then next section will provide you with a method to solve it. We are going to do that today, obviously. Take a look at one more example, and then we'll move to the next section where we learn how to solve them. So now we're going to have a system that we are going to break further. 2x double prime is equal to negative 6x plus 2y, and then y double prime is equal to 2x minus 2y plus 40 sine 3t. We need to know that x comma y are functions of t, because I don't want you confusing that with the ones that you know from algebra when you just had x plus 3 equals to 7, right? These are functions. So we just don't want to write x of t, y of t every time. All right, so to transform the system into an even bigger system, we are going to, again, use the same principle. We start with the first variable and then keep working on substitutions. So x1 is equal to x, right? And x2, which is, x2 is x prime, which is x1 prime. x1 prime. So that's what we have. And now we have the, so that's that one. And then the next one is what? Y variable. So we're going to use that one as y1 equals y. And then y2 is equal to y prime, which is 1 y prime. So what are the substitutions? Substitution is that x2 is equal to x1 prime and y2 is equal to y1 prime. Those are the conclusions right at the ends. All right, so now we want to transform all of these systems. We are starting with first statement that x1 prime is equal to x2. That's the first equation. The second equation is when we plug everything in a top equation up there. So this is a double prime on x is x1 prime, right? Which is the x2 prime, great. So if you differentiate here, you get that relationship, which is x double prime. So x double prime is, so we have 2 x2 prime is equal to negative 6x1 plus 2 y1. The next equation is y1 prime is equal to y2, which is this equation here. And then we do the same trick to transform the bottom. Y double prime would be y2 prime, which is equal to 2x, which is 2x1, minus 2y, which is 2y1, plus 40 sine 3t stays as this. Boss, done. I would probably say, isn't this much worse? We went from the system of 2 equations into a system of 4, and then we'll have to do the work later on to bring them back, which is integrals. Well, until you start doing the problems and seeing the benefit of this, you really can't judge, so don't. You have a whole bunch of problems to practice, so try it. Now, for practical purposes, when you start doing these substitutions, if you're getting lost, make sure that on the left-hand side are all first derivatives of x1, y1, x2, y2, and so on. And on the right-hand side, no derivatives of any kind with x1s and y1s and x2s and y2s. So clearly separate the two worlds, and we'll see how it is solved, but just make sure that you have all the derivatives on this side, none of the derivatives, and that you don't have any of the original x's and y's. They all have to be x1, x2, y1, y2, and so on. So that's some kind of, in layman terms, let's say, what the goal is. All right, now that we know how to set up, now that we know how to transform the systems, we are going to jump into the next section. So I'm going to restart the stream and to see how to solve them. We have enough time.